Hi there, in this video, we are going to solve practice problem 2.8 from Fundamentals of Electric Circuits Fifth edition. So you can see that we have been given with a circuit in which we have an independent voltage source of 10 volts, a 2 ohms resistor, an 8 ohms resistor, a 4 ohm resistor, and another independent voltage source of 6 volts. We have been given with various voltages V1, V2, V3, and currents I1, I2, and I3 respectively. We have to find these voltages and currents for the resistors. To solve this question, first of all, we will apply KVL, that is Kirchhoff's voltage law, on each loop of the circuit. So we will apply KVL in the clockwise direction. So for the first loop, and then KVL for the second loop. So applying KVL, Kirchhoff's voltage law, for the first loop. So now you can see that in the first loop the current is flowing in the clockwise direction. So for the 10 volts voltage source, the current is flowing from negative towards the positive, means there is an increase in potential, so positive 10. And then for the 2 ohms resistor, the current is flowing from positive towards the negative, means there is a drop in potential, so negative V1. And then for the 8 ohm resistor, the current is flowing from positive towards the negative again, so there is a drop in potential, negative V2 equal to 0. And now we will apply Ohm's law. So using Ohm's law, so for V1 I will apply Ohm's law and it will become 2I1. So 10 minus 2 ohms is the resistor and the I1 is the current flowing through it, minus 8 and the current flowing through it, that is I2 equal to 0. Now simplifying this equation, because we have to isolate I1, so 2I1 equal to 10 minus 8I2. Dividing 2 on the other side of the equation, it will become I1 equal to, we will take 2 common from the numerator, so 2 into 5 minus 4I2 divided by 2, cancelling the 2's, 2 ones are 2, so I1 will be equal to 5 minus 4I2. So this is the equation for I1. Now we'll apply KVL on the second loop, so loop 2. And now you can see that again current is flowing in the clockwise direction, and for the 6 volt source current is flowing from negative towards the positive, means there is a increase in potential. And then for the 8 ohm resistor, again current is flowing from negative towards the positive, so again increase in potential, so plus V2. And then for the 4 ohm resistor, current is now flowing from positive towards the negative, means there is a drop in potential, so negative V3 equal to 0. So again we will apply Ohm's law for V2 and V3, so 6 plus 8 I2 minus 4 I3, current is I3 flowing through the 4 ohm resistor, so equal to 0. Now we will simplify this equation and we have to isolate I3, so 4 I3 will be equal to 6 plus 8 I2. Now dividing 4 on the both sides of the equation, so I3 will be equal to, we will take 2 common from the numerator, so it will become 2 into 3 plus 4 I2 divided by 4. So 2 ones are 2, 2 twos are 4. So I3 will be equal to 3 plus 4 I2 divided by 2. Now we will apply KCL, Kirchhoff's current law, and plug these equations of I1 and I3 in it. So applying Kirchhoff's current law, that is KCL, which is the sum of input current is equal to the sum of output currents. So the input current here is I1, which is being divided into I2 and I3. So I1 will be equal to the sum of I2 plus I3. Now we will plug the equations of I1 and I3 in this equation. So it will become 5 minus 4I2. So 5 minus 4I2 equal to I2 plus 3 plus 4I2 divided by 2. Now taking I2 on the other side of the equation, it will become 5 minus 5I2. 5 minus 5I2 equal to I2 plus 3 plus 4I2 divided by 2. Now taking I2 on the other side of the equation, it will become 5 minus 5I2. 5 minus 5I2 equal to I2 plus 3 plus 4I2 divided by 2. Now taking I2 on the other side of the equation, it will become 5 minus 5I2 equal to 3 plus 4i2 divided by 2. Now multiplying 2 on both sides of the equation, so multiplying 2 here, this 2 will cancel this 2, and 2 into 5 will become 5 into 2 will become 10. So 10 minus again 10i2 equal to 3 plus 4i2. Now simplifying this equation, so 10 minus 3 will be equal to 10i2 plus 4i2. So 7 equal to 14i2, and the value of i2 will be 0 0.5. 7 divided by 14 will be equal to 0 0.5, or we can also call it as 500 milliamperes. So 500 milliamperes. So this is the value of i2. Now we will find v2 by simply applying Ohm's law. So making a small partition here, and now we will apply Ohm's law. So v2 will be equal to 8 into i2. 8 is a resistor, 8 ohm is a resistor, so 8 into i2 is 0.5, means half. So it will become, v2 will be equal to 4 volts. Now we will plug this value of v2 in the KVL equation of the first loop. So the KVL equation of first loop was, we can write it as 10 minus v1 minus v2 equal to 0. Now simply plugging the value v2, so it will become 10 minus 4 equal to v1. So v1 will be equal to 6 volts. Now we will find the value of i1 by simply applying Ohm's law again. So i1 will be equal to 6 divided by 2, that will be equal to 3 amperes. Now again we will plug the value of v2 in the equation of KVL equation of the second loop. So the KVL equation of second loop was 6. So we will write 6 plus v2 minus v3 equal to 0. Now plugging the value of v2, so 6 plus 4 equal to v3. So our v3 will be 10 volts. Now the only thing that is remaining is the value of i3. We can calculate it by using Ohm's law or by using the KCL equation. So we will use the KCL equation. So i1 was equal to i2 plus i3, and if we have to find the value of i3, it will become i1 minus i2. So i3 will be equal to i1 minus i2, and the value of i1 was 3 amperes. So 3 minus i2 was 0 0.5. So it will give us our answer for i3, that will be 2.5 amperes. So you can see that we have found all the values of currents and voltages, and that is it for this video. So we'll see you in the next one.